Hello, welcome again for the next part of the video. I am a mentor, Pauline sir. Without much delay, we'll proceed forward. Let's remember what problem we have left with last day. This was a problem I have left for you as a homework. I do hope that you have completed it. Now let's move on to the another problems which are very important. So let's start. Okay, so here is the very first problem of today. It is find the remaining zeros of the polynomial fx if you know two of the zeros are root 2 and minus of root 2. Right? There's a polynomial fx whose two zeros are given, and the rest, whatever zeros you'll be getting, that you have to decide. Now, first of all, look at the degree of the polynomial. That will tell you how many more zeros you have to find, right? So here you can check that the degree is 4. This is the highest power, and therefore there will be total 4 zeros, out of which already 2 you know. So how many more you have to find? 2 more. So let's start with how we'll proceed. Okay. So this is the first problem of this kind. So I'll write all the statement very clearly. But if I get some problems of this kind in the next slides, I'll not write the complete statements. I'll write only the mathematical expressions, right? So you try to understand for this particular problem how to write the statements. Okay. So let's start. Here x equal to root 2 and x equal to minus of root 2 are two given zeros, right? Zeros of whom? Fx. Therefore, by factor theorem, we can easily say that x minus root 2, comma, x plus root 2 are factors of fx. If they are factors of fx, then very easily you can say that the product is also a factor of fx. Is it clear to you till here? I do hope that it is very clear to you. Now that is, if you observe, this is a formula, right? A minus b into a plus b, that will give you x square minus 2 is a factor, right? Is a factor of fx, is a factor of fx. Now what exactly we have to do? Just I'll take half a minute for discussion, then we'll proceed for the main part, right? So now see, you came to know that this is a factor of fx, and this is the factor which gives you these two zeros which are given, right? Root 2 and minus of root 2. So now if this becomes a factor, then we can express fx equals x square minus 2 into some quotient, and remainder will not come because it's a factor. Factor means remainder will not be there. That means zero remainder will be left out if I divide the polynomial by x square minus 2. So by division algorithm I'll be getting like this, right? So further, if I need to find the remaining zeros, I have to factorize this gx. There is the part which I have to factorize, and once I factorize this, then I'm going to get the remaining two zeros. That's all. So now my target is to find this particular gx, and for that I have to carry a division, right? And remember, this division is not a rough walk. It should be shown. I am doing here in the side, but in your copy you'll continue with the problem, right? But this part is not needed. This part is for the explanation. So now let's start with the division, right? All of you are very clear about the long division, so I think I need not explain you more about this particular thing. So I just go on doing it, right? Just follow it. I would suggest you just stop the video right at this moment and then do the division yourself and then continue with the video and check whether you're getting correct or not, right? That's the spirit. So I'll be getting here 2x squared, getting me here 2x to the power 4, then I'll multiply it back, I'll be getting here 4x squared. 4x squared is minus 4x squared, not plus, it is minus 4x squared. And then I have to subtract. If I subtract, this will be minus, this will become plus, they will get cut, then minus 3x cube will be coming down, then here I'll be getting x squared, then 6x I'll bring down, and then 2, right? Then here very clearly you can put minus of 3x, giving you minus 3x cube, then multiply it back, it is plus 6x, then if you minus it, this will be plus, this will be minus, they will be getting cut, they will be getting cut, and then here x square minus 2, which is nothing but the divisor, so one time it will go, and then x square minus 2, leaving a remainder 0, right? So after this step, what we can observe, therefore fx is x square minus 2. Now gx you will not write. Now what you write? This is what you should write. Now you need not factorize this anymore. This one already we have obtained by the given zeros, so it's absolutely useless again to factorize. Just do the midterm factorization of this in order to identify what are the two zeros. So I again hope that you will be able to do the midterm factorization, because already we have done this, right? So once you do the midterm factorization, very clearly you will be obtaining the remaining two zeros, right? You can check here. Ultimately what I'll get here, it is x square minus 2, sorry, it is by mistake written 3, okay, it is x minus 1 into twice x minus 1, giving you the other zeros to be 1 and half, right? So these are the other zeros. So you have determined, you at last write the conclusion that the other zeros are x equal to 1 and half. Okay, that's it. Now move on to the next problem of similar kind. Here is the next. Find the remaining zeros of the polynomial if this time zeros are this, right? Now you see this time we have chosen a complicated zeros, right? So anyway, as per the previous dialogue, I'll say I say it that I'll write only the only the mathematical statements, right? So very clearly you can say that x minus root over 5 by 3 comma x plus root over 5 by 3 is a factor of fx, is a factor of fx. So if you multiply this, what you are going to get, x square minus 5 by 3 is a factor of fx, right? Very clear. Now instead of keeping it like this, we'll try to simplify by taking the LCM. So this will be also a factor of fx, and because of being polynomial we can avoid this 3. If we avoid this 3 also, whatever numerator will be there, that will be also a factor of the original polynomial, right? Why did we do this instead of this? Because if we can avoid the fraction, then we'll be getting our divisions easier. Okay, so now we have to divide the given polynomial with the help of 3x square minus 5, and here it is the given polynomial. So now do that. Okay, so now you divide it, it will be how much? It is x squared. Like the previous case, what you can write now, fx will be equal to x square minus, sorry, there's a 3 here, 3x square, 3x square, 3x square minus 5 whole into x square plus twice x plus 1. Now this you need not again factorize, you only factorize this part. Now you see, it seems that there is only one factor. Factor is only one, but it is repeated for 2 times. That means x plus 1 into x plus 1. So what are the zeros here? Minus 1 comma minus 1. So write the conclusion yourself. Therefore the other two zeros are minus 1 and minus 1. Remember, this is a very important problem. It is from the book. It is from the book. It is very important problem. Very important only because of this structure of the zeros, right? Let's move on to the next problem. So let us start with the problem, right? We'll have to only remember this thing. Always remember, degree of the dividend is equal to degree of gx, that is the divisor, plus degree of the quotient, right? This is the relation we have to use for doing this. Okay. So now here, of course, in the given question, the value of or the name of fx has been written as px. So there is no problem. So if we get this, which will satisfy division algorithm, that must be also a statement. So here by division algorithm, division algorithm, what you will get? Px will be equal to zx into qx plus rx. Okay, conditions of rx you write here. Whatever conditions it will satisfy, r equal to 0 or like this. Therefore, we'll be immediately getting this particular response, right? This is degree of gx plus degree of qx, right, from here. Okay, now you observe here, degree of px and degree of qx are equal. That means this quantity is equal to this quantity. So from here, what you can conclude? Degree of gx must be 0, right? So since degree of px is equal to degree of qx, therefore degree of zx must be equal to 0. That means zx is a constant. Gx is a constant. Gx is a constant. Gx is what? Divisor, right? Gx is divisor. That is, divisor is a constant. Obviously, it will be non-zero. So we'll write this as k. Say this divisor be k. Divisor be k. Fine. That means we can write in place of gx some k. For considering examples, you can assign any value of k, 2, 3, 4, 2 by 3, root 3, anything. Now all that we need to now talk about is about Rx. What is Rx? See, we have to remember one very important part, that is Rx equal to 0, or if Rx is not 0, degree of Rx is always less than whose degree? The divisor. Now in this particular problem, what is the degree of divisor? It's 0. Now what is the number less than 0? It will be negative, but degree cannot be negative, right? Polynomial demands only that thing. So degree cannot be negative means for this particular question, this part is not true. If this is not true, that means Rx must be 0. So in this polynomial, that will imply that Rx is equal to 0. Therefore, if Rx equal to 0, what will be Px ultimately will be? It will be Px equal to k times Qx. Now, because they are asking examples, you now consider k to be say 3 or anything and Qx to be any polynomial. Qx to be any polynomial and remainder will be 0, right? Okay, that's it. That's a very important conceptual problem. So you must be very clear about that. If in the first go you are not clear, please replay the video, right? Do it fully and make sure that you understand this. Move on to the next one. Okay, so this time it is a part of the same problem. Degree of qx should be equal to degree of rx. Degree of qx should be equal to degree of rx. Okay, first of all, you remember this thing, right? You remember here, it is not necessary that every problem you will write to show it, but if you remember it and you write it in front of your eyes, then it will be easier for you to observe. Degree of qx, that is this quantity, should be equal to degree of rx. Qx means what? Qx means the quotient. So here, of course, those controversy will not come because this is not going to relate rx. Okay, rx is independent of this. Only thing is that rx should have a degree less than gx. That's the point you have to remember. So now we'll directly consider, right? We'll consider one qx, you consider anything, say x squared plus 1. So Rx, the degree should be same, means Rx should be also containing x squared, no matter whatever is the coefficient, right? I put a coefficient this and then let me make the remainder little bigger than 2x. Let it be the remainder. So are they satisfying the given conditions? Degree of qx equal to degree of rx. Very fine. Now what exactly you need to complete px? That is the gx, right? That is a divisor. So divisor should be now what? You be very careful here, very careful, because you have considered the remainder to be a polynomial of degree 2. So it is very important to consider gx, that is a divisor, to be of at least degree 3, right? It cannot be of 2, it cannot be of 1, it should be minimum 3 in our example. So you can consider a very small divisor, that is not an issue, but you consider this. And after that, you just find the quantity px equals gx multiplied by qx plus rx. You work it out, something you will get. Whatever you will be getting, that 4 will give an example which will satisfy this. So I do not want to now work out px for you. You work out, make sure that it is satisfying this particular result. Okay, go on to the next problem. It is a part of the same problem. Px, Qx, example you have to give, degree of Rx should be 0. It's a very easy problem. It's a very easy problem, right? Everyone can give it. But do not start with Px. Px should be found. You start with Gx. Anything, do not consider bigger. This time anyway, we haven't considered bigger polynomial so far. We have considered it. Qx, how much I can consider? Smaller one consider. And Rx already 0. Degree of Rx 0. Degree of Rx 0 matlab what I should consider? Degree of Rx 0 does not mean, degree of Rx 0 does not mean that it's 0. It is a number, it's a constant number. Let me consider this as 4. And then what you can find? What is Px? It will be just obtained by multiplying all this and adding Rx to it. So after calculation, you will be getting in your hand this polynomial. One is Px, other is Qx, Zx and Rx, and that's what are the required example as they are asking. Okay, fine. I hope that you are not finding any problem here in understanding this. Okay, move on to the next. Fine. See, these are small problems. Just to bind up the chapters, I'm taking these problems. After like 2 or 3 months, I'll be coming with revision slides for polynomials. Then we'll discuss some other different level problems. Presently, we are in the ground level problems which are related to your book directly. Okay, how many zeros does the polynomial x minus 3 whole squared minus 4 can have? Find. If you need to find how many zeros are there, you need to know the polynomials, right? So polynomial is given. Only thing is that it is not in the reduced form. So you break this. You break this, right? You break this. And once you break this, what you will get? You are going to get this polynomial. So what is the degree of the polynomial? 2. So how many zeros it will have? It will have 2 zeros. Okay, right at this moment, I'm not sure whether they are real zeros or not. But I'm sure that they will be having 2 zeros. Of course, they are asking you to find the zeros. Now we'll come to know whether zeros will be real or not. So normally, how do we proceed for solving quadratic polynomial? Yes, you guessed it correct. We'll try to do the factorization, right? We'll try to do the factorization. So it is 5x minus, sorry, yeah, 5x minus x plus 5. So I can take x common, this much, then it is x plus 5, and then x plus 1 all into x minus 5. Sorry, there is a mistake here. It is a minus sign. So it is x minus 5. So what are the zeros? This will be also minus. So x equal to 1 and x equal to 5 are the zeros. So you are done with the problem. This is a small problem. In the board, if it comes, it may be carrying 2 marks, or maximum it will be 3 marks, not more than that. Not more than that. Okay. Come to the next problem. This is the last problem of today as well as for polynomial. Alpha and beta are two zeros of the quadratic polynomial x squared minus 6x plus y. Find the value of y if 3 times alpha plus 2 times beta equal to 20. Right? 3 times alpha plus 2 times beta is equal to 20. Alpha, beta are the zeros. So I'll not write much statement. Just you write, given that alpha, beta are zeros of the quadratic polynomial, this, then what is a, what is uh, b. If you compare, what is a? 1. What is b? Minus 6. What is c? Y. Right? Be careful. This time we are not considering this as a variable. That may be a silly mistakes coming to your mind, right? So what is alpha by b? Alpha plus beta? It is minus b by a. What is alpha beta? C by a. See, I'm not taking a big reference here. These are some of the zeros. This is relation of the coefficients. So we are directly using it. Alpha plus beta, right? Alpha plus beta will be now how much? Put the value. What is b? B is minus 6. What is a? 1. So that gives us alpha beta equal to how much? 6, right? Now you see, we do not need absolutely or presently this particular relation, because first of all we have to determine what is alpha and beta, right? So anyway, I'll keep it ready because ultimately we'll be needing it. Alpha beta will be written like this only. C is y and this is a is 1. So y is nothing but alpha beta. So once you get alpha and beta, then you can find the product, which is nothing but y. So this is one of the equation we arrived at. Another equation is already here. So how we'll proceed to solve it? From equation 1, we'll be finding the value of alpha in terms of beta, and this particular value of alpha we'll put here, right? So okay, this is 1, this you mark as 2. Therefore 1 implies 3 times. Place the value of alpha here, and then twice beta equal to 20. Get it simplified. It is 18 minus 3 beta, then plus 2 beta equal to 20. Then what you will obtain? It will be minus beta. Then this, if you transfer, minus 2. So what is beta equals? If beta equals to what is alpha equals? Put here, it is 4, right? If alpha and beta you find, therefore what is y equals? Alpha into beta, that is 8. Great. So you have found this. Very shortly I'm going to upload assignment for you with extra questions. So please do visit my blog. My blog already I have shared. Now again I'm sharing. Please do visit the blog and please do subscribe. Young Mathemaniac dot blogspot dot com. Right, till the next chapter, we'll be starting with the next chapter very immediately. Till then, bye bye, and please do subscribe my YouTube channel and the blog for getting more informations and more study materials. Till then, bye.